So my name is Ashok, and I'm an engineering leader with a company called TransUnion. So we do credit bureaus across the world, and I head a quality engineering team that basically tests credit bureau solutions, and we deploy these solutions across 33 different countries worldwide. So that's about my work part. And I've been associated with the testing domain for close to 2 decades now. And my area of specialization within testing is around test strategy, leadership, customer advocacy, and test automation. And outside of work, I also publish blogs in external testing communities. And I'm also a speaker. Obviously, I speak in multiple international conferences as well as local events that happen within my country, but also outside of India as well, like Houston. And I'm also passionate about mentoring young test engineers who are new to their testing careers. And I offer guidance wherever possible. So that's a brief about me. Now, while I was preparing for this talk, putting together my slides for this talk, I came across this picture. And I think this resonates well with what I want to convey as a message to you all through my presentation today. Now, the banner that you see there, right, that is your your smoke testing process. Ideally, that is the smoke testing that needs to run in your test environments. And the bridge that you see there is the test execution life cycle that we as testers go through. Now, if you're able to pass through the banner without hitting the banner, obviously you will also be able to pass through the bridge. Now, that's a happy path. On the contrary, the reality is different, correct? So every time we pass through the banner, we try and get stuck there. But it's fine. It's good because you have a smoke testing process already there in your environment. But if you don't have, that's a different problem to solve. Okay. Now, when you get stuck on that banner, you can still course correct, you can fix things, you can change things before you pass through the bridge so that you will be successfully able to pass through the bridge as well. The bridge is your test execution life cycle. So when you actually go through the test execution life cycle, you will not have much of hiccups in terms of application stability. Now, smoke testing is basically a testing technique that smokes an application to test the ability of the application to stay stable or not. Now, this sort of a testing process needs to be executed way before your actual test execution starts. So that's when you can actually solve problems, fix problems with the application stability much before. So that when you start your test execution, you don't need to have to go through all of those problems and issues with sorting out the application stability problems. So the need for smoke testing as a test process, I wanted to talk about this need from two different perspectives. So the first perspective is the perspective of the industry analysts. So these are people who research the software testing market or software development market and publish their analyst findings. So some of the very well-known analysts are Gartners and Forresters. So I wanted to quote a few studies from these analysts as well. So a recent study by Gartner indicates that nearly 25% of test execution time is actually wasted for teams because they do not have a stable test environment in place. Now, what this will lead to is that testers come in to start their test execution, and then they find that certain applications in the environment have gone down. Now, they cannot proceed with their testing. So their test capacity is now become idle, and it is not being managed effectively. Another study by Forrester also indicates that of the overall test execution life cycle, of the complete time that you do test execution, 50% of that time, your test environments are actually not available to you. So this is also causing that test capacity being managed ineffectively. And a study by Capgemini also states that of all of the defects that teams log during their test execution. 60% of these defects are actually environmental problems. They're not functional defects. They are not performance-related problems. First, they deal with environment problems. And these 60% defects could have ideally been fixed, identified much earlier, even before you start test execution. So you're actually doing 60% of the work which you should have done earlier. The same study by Capgemini also reveals that nearly 80% of the teams report success with their test automation when they have a stable test environment. So when your environments are stable, you are more likely to have success with your test automation because of all of the flakiness that happens with your test automation. All of that can be, to an extent, managed when you have a stable test environment. So now that we've seen an industry's perspective, I also wanted to talk about an insider's perspective. Now, by insider's perspective, I mean perspective of teams like us. When we initially wanted to implement smoke testing, we identified certain key objectives that we wanted our smoke testing to solve for us. Now, the first objective was we wanted our smoke testing process to monitor or have the ability to monitor our environment stability and also help us alert if there is any problems within the application stability in the environment. Whenever they happen, we need to be able to be alerted about it. And when testing capacity, when you are upfront informed about the problems in your application stability, obviously you will also be able to manage your testing capacity much more effectively because your instability problems are being reported even before you start your actual test execution. So your testing capacity doesn't need to be wasted, or you don't need to sit idle when you start your execution. When you start your execution, all of the applications in your test environment are more or less up and running because you would have fixed all of that earlier through your smoke testing process. Now, as we matured into our agile transformation journey, as all teams do usually, right? What we noticed a trend among our developers who wanted to check in code much more frequently into the environment. Now, while this is good from an agile perspective, it also has a problem associated with it. Now, that is a problem of frequently pushing untested code into a lower environment, which can adversely impact the stability of that environment. So we wanted our smoke testing process to ideally create a feedback loop that will help us to give feedback to our developers and stakeholders about the stability of our application, and also will most likely be like a safety net for them to actually check in code much more frequently into the environment. So considering all of these objectives, we put together a reference architecture. And the lower part of the architecture that you see there is your smoke testing applications, or the applications that needed to be smoke tested. Now, we invested a lot of effort in identifying the actual checks that need to be included into our smoke testing pipeline. And I'll talk about the checks and the problems with these checks in the later slides. In terms of automation frameworks, what we did was we directly reused from our regression automation whatever frameworks we had for these applications and repurposed them to work for smoke testing as well. Now, all of these smoke testing jobs were configured into a Jenkins master node, and they were scheduled to run on specified time intervals. The Jenkins master itself was configured to multiple Jenkins agent nodes. And each of these agent nodes had the capability to execute smoke jobs parallelly. And we also had a mechanism called agent monitoring, which is an automated way of monitoring the health of the Jenkins agents itself. And that capability also had additional features whereby we could restart a Jenkins agent if it goes down. So it is kind of an auto-healing mechanism that we implemented for the framework. Now, within each of these Jenkins agents, we also configured multiple executed threads. These are parallel threads that had the capability to spawn smoke test jobs parallelly. So if you see, we have got parallelism achieved at the agent level through multiple Jenkins agents. And within the agent as well, inside the agent as well, we had executor threads which had the capability to execute smoke jobs parallelly. So this sort of a parallel execution helped us to actually fast track our feedback that we expect out of a smoke testing implementation. So we were able to get very, very rapid feedback from our smoke testing executions. Now, some of the common pitfalls that teams tend to get into when they initially start implementing smoke testing is that they tend to create bloated checks. I mean, by bloated checks, what I mean is that when your smoke check tries to be a lot more holistic and trying to also test the functional validity of an application or the regression capabilities of an application, that's when your smoke check becomes a bloated check. Now, the problem with these bloated checks is that they slow down the overall feedback that we expect from a smoke testing. The other problem with smoke checks is that we tend to design these checks more towards the UI layer and less towards the database and the service layer. And there are two problems associated with UI checks. The first one being UI checks are inherently heavyweight, and they again add to the problem of slowing down the overall smoke feedback we expect. And UI checks are also flaky, which means that there is a possibility of injecting a lot of false or negatives into your smoke testing report. Now, when we initially started implementing smoke testing, we had two choices in front of us. So the first choice was we build a customized framework with all the capabilities of a test automation framework like reporting, monitoring, external data stores, all of that, specifically for smoke testing. Or the other choice that we had was directly lift and shift from our existing regression test automation, all of these frameworks, and reuse them for smoke testing. Now, we went for option 2 because we didn't want to over-engineer our frameworks, and we also wanted to quickly kickstart our smoke testing implementation and start gaining value out of it. As we started executing our smoke testing pipeline, what we noticed was there were a lot of failures that gets reported into our smoke testing reports. Now, when we did a deep dive on these failures, we noticed that these were actually not failures because our application stability was going down, but many of these failures were because the underlying infrastructure on which our smoke testing jobs were running, they were actually becoming flaky. In our case, that infrastructure is our Jenkins agents. So that's when we implemented our agent monitoring scripts to monitor the infrastructure layer as well, so that we are able to actively remove the noise out of the smoke testing signal that we were projecting to our stakeholders. Finally, we needed to achieve the right balance between how much coverage we have through our smoke testing and how fast is our feedback from our smoke testing pipeline itself. Now, in a testing technique like smoke, speed is very, very important. And that needs to be rightly balanced between how much coverage you enable through the smoke pipeline itself. Now, some of our key success metrics from our implementation is that we were able to smoke check 21 applications with 40 atomic checks in an overall execution time of 9 minutes across 3 different environments, SIT, UAT, and prod. And overall, we have logged 33 defects so far. These were all environmental problems, problems with stability of the applications within the environment, which could have ideally stalled our test execution effort if we wouldn't have identified them and fixed them earlier through this sort of a smoke testing process. Now, looking into the future, some of the key initiatives that we are currently working on with regards to smoke testing is that we will consistently optimize for speed, which means that we are trying to remove any bloated checks that still exist within our smoke testing scope and trying to convert them to a lot more nimble and atomic checks. We always aim to tilt the balance towards API and service layers. And the one metric that we use to do all of these optimizations is that we use the overall execution time of our smoke testing pipeline. Now, right now, we are at an overall execution of 9 minutes, as I said before. What we want to do is we want to go to 6 or 7 minutes. And that is without compromising on coverage. And that's the metric towards which we're working on for this optimization. The second initiative that we are working on is building a customized reporting dashboard on top of Grafana, and that will provide reporting capabilities to our smoke testing pipeline itself. And one of the key asks from our stakeholders is that how do we see a report where they can show a trended view of, or they can see a trended view of how an application transitions from a state of stability to a state of instability over a period of time. So these are complex reports that our stakeholders ask for. I think most of the stakeholders expect this sort of a reporting, and that can be vice versa as well. How does an application transitions again from a state of instability to stability over a period of time? So these are the reports that we are trying to build on top of this customized reporting frameworks. And the third initiative is we're also trying to build a machine learning model that has the capability to train on top of our past smoke testing logs, and possibly have the capability to predict which type of check-ins on which applications can potentially bring down the stability of the application, even before the check-in is made into the environment. So we are trying to shift left our smoke testing itself. And these are some of the cool initiatives that we are currently working on. And I would be able to give you more insights about how we implemented them and what challenges we have while doing this work in the upcoming conferences of Houston as well. Thank you. Thanks for your time.
Thank you, Ashok. Let's see, you got currently 2 questions. Okay, 1, I don't know what happened. Okay, 2. So let's see the first one from Borna. What is the suggested coverage for an application with a smoke test?
Okay, that again depends, right? There is no golden thumb rule that you need to have this much of coverage for smoke test. What you need to always remember is that you shouldn't be over-engineering your coverage aspect. So the more you over-engineer, the lesser will be the speed with which you get feedback out of smoke testing. So it's like it depends on the application and the technology stack in which that application is built. For a web application, what we have done is, as I've told you, 21 applications that has an overall smoke check coverage of 41 smoke checks. So it is roughly around 2 to 3 checks that we have per application. But that again depends on what technology stack, what application that you are testing.
Okay, thanks. The second question is that where is the line between smoke and any other non-smoke test? We tend to call basic functional tests smoke tests, but apparently we are wrong.
Yeah. So this is a very important aspect because you need to understand the difference between what are you trying to achieve through a smoke testing. So as I delivered in my talk as well, smoke testing is a testing technique that has the ability to smoke an application to test for its stability. That's it. So you shouldn't be trying to test for functional coverage of an application or the end-to-end regression of an application. All of that will make your check quickly bloated. And you will not gain the value out of a bloated smoke test.
Okay, next question. What is the opinion? What are the best phrases, key sentences to convince devs smoke tests are needed?
Okay. So the best approach is it makes their life easier. So anything that makes their life easier, they will be supportive of it. So try talking to them that way. I think the problem here is they don't understand our world. And it is also our job to bring them into our world and try to make them understand what we are trying to do. If they become cognizant of the fact that we are only trying to help them, we are only trying to make their life a lot more better, then I think it should be easy for you to convince them.
Thanks. Now regarding also, how do you select smoke test cases from regression test suits?
So if you understand the objective of smoke, you should be able to select those test cases from regression. So what we do is we check the very basic functionalities. If it's a web application, we check if we are able to bring up the web app on the browser. We check if we are able to log into the web app. That's it. So these are already test cases you would have automated, you would have kept ready in your regression packs. You can just pick and choose them. But the objective, you need to be very, very clear. When you're unclear about the objective, that's when you get into that bloat.
Okay, what metrics from Grafana do you use to generate reports for stakeholders, taking in consideration that the stakeholder is more business oriented?
Yeah. So on that question, right, I want to be clear that we are right now not giving data, I mean, giving reports from Grafana directly, but we are working on that step right now. And as I said, the ask from our stakeholders and business owners is that they want to see how an application transitions across stages. So they don't want to see at this point in time your application is stable or not. What they want to see is over the past 2 weeks, based on your smoke test report, how did this application move from a state of stability to a state of instability, or vice versa? So these are the reports that we are trying to build on top of Grafana, because Grafana has those capabilities of visualization. And we also have the data already, because we are running it on a daily basis, and we have the data. So we just have to mix and match the data and visualizations. But from a stakeholder perspective, this is what is their expectation.
Okay, there is one last question here from Roland. What is your opinion? What is better? Smoke with automated test case in 9 hours without human work, or manual smoke tests within 1.5 hours?
I think both are worse, because a smoke check shouldn't be done for 9 hours. So I think you should start, I mean, I'm not advocating for doing it in automated way or doing it in manual way, but what I'm trying to advocate is running a smoke check for 9 hours is not going to give you the value that you expect out of it. It's not going to give you the quick feedback. It's going to make your developer's life even more worse. So they will not support you. So try and find ways to minimize the time. Then the time that I showed you is 9 minutes. I'm sorry if it got miscommunicated. It's 9 minutes, not 9 hours in our case. But we're trying to bring it down even further to 6 or 7 minutes.
Okay, we still have like 1 or 2 minutes, so
yeah.
Maybe this one, thoughts about smoke testing in prod?
Yeah, we do that. I mean, we run our checks in prod as well. That is also helping us from very, very primitive observability kind of method as well. So we also are able to find problems with stability in production applications as well. And that can be due to any reasons. I mean, we do a lot of testing in our lower environments, but still when we push code into production, there is a element of risk for applications to become unstable. So we want to minimize that element of risk as well, and that is why we also run our tests in production.
Okay, maybe one last question from my side, because we also have smoke tests in our team, and I'm really curious, based on what or how do you decide how often do you have to refactor or update the smoke tests? Because yeah, you run them as fast as possible and each time, but maybe after a while they would be green if there is nothing new developed. So do you refactor them? Or?
We do refactor them because we monitor our smoke check results on a daily basis. And if we see flaky behavior on our smoke test as well, we try and refactor them. And we also look for positive signs as well to refactor. For instance, when a test keeps passing for a long time, maybe 3-4 months, then at that point also we try and refactor the test. We actually double click on that test and see if it is actually testing what it needs to test. So that is also one of the levers for refactoring for us.
Okay, Ashok, thank you very much. Once again, another round of applause for Ashok.
Thank you.
Thank you very much that you were here with us.